You can track every calorie, buy the highest grade organic produce, and carefully curate your entire diet. But the way you apply heat to those ingredients can create chemical changes that undermine your healthy choices. The culprit is a class of microscopic compounds known as polycyclic aromatic hydrocarbons, or PAHs. The process is cyclical. When fat and juices from meat drip down onto a hot surface or an open flame, they combust. That creates a smoke loaded with hydrophobic organic compounds, which drifts right back up to coat the food. We rely on heat to kill off bacteria and make our meals palatable, but that same thermal reaction is simultaneously lacing our food with an invisible chemical hazard. The National Cancer Institute notes that animal studies repeatedly link exposure to these high-temperature cooking compounds to severe forms of cancer. Keeping these compounds out of our bodies requires actually measuring them, and historically, that has been a challenge. Conventional laboratory techniques like solid phase or liquid-liquid extraction are notoriously inefficient. They force lengthy preparation cycles that demand intense manual labor, all while relying on large amounts of harsh, environmentally toxic chemicals. Because the extraction process was so exhausting and hazardous for the testing labs themselves, it limited how often these compounds could be monitored, creating a blind spot in the safety data of our food supply. That blind spot is narrowing thanks to a streamlined analytical method called QUEACHERS. It stands for quick, easy, cheap, effective, rugged, and safe. Scientists introduce a solvent called acetonitrate to separate target PAHs from the food matrix. Sorbents act as a microscopic sieve to strip away debris. Gas chromatography then pinpoints contaminants at detection limits of 0.006 to 0.035 micrograms per kilogram. Beyond accuracy, the procedure achieves nearly 100% recovery rates, while reducing both operational costs and the hazardous chemical waste typical of older labs. What used to be a sluggish bottleneck in the laboratory is becoming a scalable, real-time safety net for the commercial food supply. When researchers pointed these precise tools at everyday grocery items, the findings revealed exactly where the toxins accumulate. Foods subjected to prolonged smoke exposure ranked near the top. Heavily smoked items like dried fish products and meats charred on an open grill were saturated with the contaminants. The concentration data shows high risks extending beyond charred meats. Certain fats harbor the highest levels of PAHs. Soybean oil, duck meat, and canola oil outscaled other baseline ingredients when heated. On the opposite end of the spectrum, researchers tested dozens of cereals and derived grain products, finding almost zero measurable PAHs inside them. Contamination in our meals follows a predictable pattern, concentrating in specific fats and extreme heat environments. We now have a precise map of where the danger lies. Commercial safety inspections can stop contaminated ingredients at the factory, but regulators cannot inspect what happens on your stove. Once the groceries are in your house, quality control is your responsibility. Water-based cooking techniques, such as boiling and steaming, represent the lowest risk for creating these hidden compounds. This matrix highlights the threat levels. As you move into ambient heat methods, like roasting and baking, the risk rises. The danger curve spikes when you reach direct contact frying and open flame grilling. The temperature and the specific medium transferring that heat dictate the biological risk. The home cook effectively manages the chemical safety of the meal. The first intervention is straightforward: lower the temperature. By pre-cooking meats in a microwave or oven, you reduce the time those proteins spend exposed to direct, scorching flames. Next, physically block the chemical reaction. Select leaner cuts of meat so there is less fat to melt, and swap out open grill grates for solid pans. If the juices can't drip down into the fire, they can't combust into toxic smoke. Finally, apply the lab findings to your pantry. Replace high-risk liquids like soybean and canola oil with alternatives that structurally resist chemical degradation under extreme heat. Through these specific adjustments, pre-cooking, choosing solid metal pans, and upgrading your oils, a dangerous meal prep process becomes an engineered, chemically safe routine. The work happening inside food science laboratories provides the data needed to make safer decisions right at the stove. By understanding the invisible chemistry of cooking and leveraging modern extraction data, we can actively engineer carcinogens out of our diets and protect our long-term health, one plate at a time.